Hello everybody, welcome to Trans-E Learning Physics videos. Today we'll be discussing about projectile, and in that we'll be covering the topic projectile fired horizontally from a height. We have already discussed about the vertical and horizontal motion equations, the formulas and SWOT equations. So in this video we'll just summarize the horizontal and the vertical motion equation, the formulas and the SWOT equations, so that it becomes easy for us to do the numerical problems. So let's start. First of all, summary of horizontal and vertical motion equations. A projectile possesses horizontal motion with a constant velocity and vertical motion downwards with constant acceleration. Before explaining these 2 points, I would like to discuss the equation, and first of all, the alphabets assigned to different parameters. X represents the horizontal distance, U represents the initial velocity, so Ux represents the initial velocity in horizontal direction, T is the time of flight, and AX represents the acceleration due to gravity in horizontal direction. Y represents the vertical distance, UY represents initial velocity in vertical direction, and AY represents the acceleration due to gravity in vertical direction. So while considering the horizontal motion of a projectile, we take the initial velocity in the horizontal direction as u and acceleration due to gravity in the horizontal direction as 0. Why we are taking this 0? Because there is no change in velocity in horizontal direction. That means the horizontal motion of projectile is due to uniform horizontal velocity. Here, that is why I have written constant velocity. As the projectile moves the horizontal distance with constant velocity, so the acceleration due to gravity in the horizontal direction is taken as 0. So now if we substitute these 2 values in the above equation, we get x equals to u t plus half into 0 into t square. So this whole will become 0, so x equals to u, and we can write t equals to x upon u. So we can use either of the equations for finding their horizontal distance or the initial velocity or the time of flight. While considering the vertical motion of the projectile, we have to take into consideration the constant acceleration, because the vertical downward distance traveled by the projectile is due to constant acceleration due to gravity, that is g, and its value is 9.8 meter per second square. So that is why we have taken the initial vertical velocity as 0, because the body is falling under the effect of constant acceleration. It's like a free fall, and the downward acceleration is taken as, that means the acceleration due to gravity in the vertical direction is taken as g. I am taking the downward direction of the gravity as positive. So if we substitute these 2 values in this equation, we get y is equals to 0 plus half gt square. So y will be equals to half gt square. So using this equation, we can find the vertical distance, we can find the time of flight. One more important point I would like to mention here is that horizontal and the vertical motion are always independent of each other, and there is only one force acting during the flight of projectile, that is the force of gravity. We are neglecting air resistance. Now we have understood the horizontal as well as the vertical motion equations. Let us review the formulas as well as the SWOT equations. First of all, the formulas. Before proceeding to the formula, I would like to tell you what is meant by the different alphabets used here for different parameter. T, capital T, stands for time of flight. Sometimes we will be using the small t also. R stands for the horizontal range. X stands for the horizontal distance. Y stands for vertical distance. H stands for the height. G stands for acceleration due to gravity, V stands for final velocity, and U stands for initial velocity. So if we need to find the time of flight, then the formula is T equals to square root of 2h upon g. If we need to find the horizontal distance or the horizontal range, then we can use U into T, time we can use in this case. Or if we substitute the value of time of flight here in this equation, then it's become u square root of 2h upon g. And if we need to find the time of flight, we can find using this equation also. We just have to arrange the equation. T will be equals to horizontal distance upon the initial velocity. Now, if we want to find the final velocity, that is equals to square root of initial velocity square plus 2 into acceleration due to gravity into height. And the vertical distance is equals to half acceleration due to gravity into time of flight square. Now let us study about the SWAT equations, or what we call as kinematic equations. Both the names are used to express these three equations. Before proceeding further, I would like to tell you what is meant by SWAT. Here S stands for displacement and U stands for initial velocity, V stands for final velocity, A stands for acceleration, and T stands for time. So this comes out to be SWAT. We have three SWAT or kinematic equations. Only difference lies in expressing them in terms of horizontal motion or vertical motion. Like the general equation is V equals to U plus AT, but for the horizontal motion we will add the subscript as x, which stands for horizontal distance, and for the vertical motion we will write subscript as y, which stands for the vertical motion. The second equation is v square minus u square equals to 2ax. For the x-axis we will use the subscript as x, and for the y-axis we will use the subscript as y, and ay is equals to acceleration due to gravity. And the third equation is s equals to ut plus half at square. Here I have written s stands for distance. So when we are taking the horizontal distance, we will use x equals to uxt plus half axt square. For the vertical motion, we can use y equals to uyt plus half ayt square. Here, instead of y, we can write h, and instead of ay, we can write g. So this can be written as h equals to uyt plus half gt square. So that was all about the quick recap and the summary related to projectile formulas, equations. Thank you very much for watching this video. For more videos you can visit our website transelearning.com. Have a great day.